Yeah.
I
So
got.
I sent you
Uh-huh.
on like the pages that my homework was on. Yeah.
Okay.
Yep.
You tell me where you want to start.
All right. So the first section is 1 through 17.
Okay. Number one, which one is the distance between the two parallel
Um, the distance between the two parallel lines,
lines?
like
In other words,
uh,
the top line is parallel with the bottom line, but
yeah,
we've got four different lines there. Which one is the closest?
A, like
Yeah,
like the line that
AB.
connects A and B. Yeah.
AB. And
Yeah.
why?
Because it has like a right or a 90-degree
That's the
or like
reason.
a right angle.
That's the reason. In other
Yeah.
words, CD also looks perpendicular, but
Hmm.
they didn't put any mark that said it was. So
Yeah.
that might actually be like 91 degrees or 89 degrees or something.
Okay. Yeah.
And then EF is clearly not 90, nor is GH. The only one that's marked perpendicular is AB, and it's the perpendicular distance that's always the shortest.
Okay. Yeah. So it would be like to write it. It says like for the first one. So
Well,
vocabulary. So like are we supposed to write like a theorem or postulate that says that?
the theorem you would want to write would be the shortest distance between two parallel lines is a line that is perpendicular to both.
Okay.
That's the explanation of it. Now,
Uh-huh.
there may be a theorem. Yeah. If, well, now hold on. I'm looking in a book, and I have the same book as you. I don't see one for this one, but let's go on anyway.
Okay.
Because the next three questions are the next three theorems in my chapter 3.2. But
Okay.
it looks like maybe it's your chapter 3.6.
Yeah. It's
In,
yep.
in
3.6 exercise.
In my book, it's theorem 3.1, 3.2, and 3.3.
Okay.
Apply to the next three problems.
Okay. Yeah.
Now, see if you can find the equivalent in your book. And they won't
So
necessarily be called 3.1, and they may be called 3.6. In other words, there's no master database of theorem numbers.
no. Uh-uh.
So the
Yeah.
theorem is true regardless of which country in the world you're in,
Uh-huh.
but what it would be called in terms of a theorem number would be different.
Okay. Yeah.
Problem number two relates in my book to what is called theorem 3.1.
Okay.
And in fact,
Yeah.
it shows the exact same picture.
Okay.
And
Yeah.
it says if two lines intersect to form a linear pair of congruent angles, meaning one is equal to two,
Yeah.
then the lines are perpendicular.
Yeah, that's what
And
yeah.
the reason that is because we know those lines are supplementary.
Uh-huh.
So if
Yep.
one is equal to two, they have to both be 90 degrees. That's the only possible answer. And 90 degrees means perpendicular.
Okay, so just be theorem 3.1.
Well, not necessarily in your book. The reason I'm a little puzzled is because this says 3.6 exercises. Now, the only difference between our books is the edition.
Uh-huh.
You may have a later edition than I have.
Okay, yeah.
And
You know what?
sometimes they change. They'll take out subchapters and stuff, and they'll change the order of things.
Okay.
So
I have a paper that has like all the theorems on it. Can I go get that real fast?
yes, definitely.
Okay, cool.
Definitely.
Just a sec.
You want
Okay. All right. Okay.
It's
So
important. It's important to understand that you don't need to memorize the theorem number.
no, just
Ever.
like the
You just
no.
need to know what it means
Okay.
and what the consequences of that are.
Okay.
In other words, you can tell that if in this problem, if 1 is equal to 2, which this little mark means, those 2 marks mean 1 is equal to 2, well then you know they're supplementary, so you know each one is 90. That means j is equal to k. Whether you know it's theorem 3.1 or whether it's called 3.6, or even if it says if 2 lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. It's not even that important that you memorize that wording. I know you need it to pass this test, but trust me, going forward, the only thing you need to memorize is the essence of these theorems.
Okay.
Not the theorem numbers or the theorem precise definitions.
Okay.
Okay.
Yeah.
Now, number 3.
Okay, so like, I'm just like confused. Like, so for number 2, like, I'm just confused on like what theorem it would be.
It says write the theorem that justifies the statement.
Yeah.
Well, here's the theorem. Let me give it to you exactly.
Okay.
Here's your perfect answer for number 2. If 2 lines intersect to form a linear pair of congruent angles.
So if 2 lines intersect to form 2 linear angles.
No, to form a linear pair of congruent angles. Then the lines are perpendicular.
Okay.
Do you have your book?
I do, yeah.
Open it up and see if you can find that theorem. Because it'll be easier than having me read it word for word to you.
Okay, yeah.
Because the next 3 problems deal with the first 3 theorems of my subchapter.
Okay. So, let's see.
Now, I suspect it's probably chapter 3.6 in your book. In the beginning.
Yep, I got it. Yeah.
Okay. So what do they call the first theorem?
So it says if it's theorem 3.8.
Okay. Well, that just shows you that the number doesn't mean anything.
No.
Because in my book, it's 3.1, and there's no. It's not like there's a master math book that it's
Yeah.
What's
so
important. Okay.
So it says like what you said. If 2 lines intersect to form a linear pair of congruent angles, then the lines are perpendicular.
Okay. Now look at the next problem.
Okay.
How do we know that 4 and 5 are complementary? Read the next theorem. It's probably theorem 3.9.
Yes, because it has right angle symbol to it, so we know that the angle is 90 degrees.
Read the theorem.
And then it says if 2 sides are adjacent, acute angles are perpendicular. No, if 2 sides of 2 adjacent angles are perpendicular, then the angles are complementary.
That's what you want to answer for number 3.
Okay, so if... Okay. So if 2 sides of... What was it? Of 2 adjacent angles. Okay.
Now, notice number 4 is the theorem right below that. At least in my book, all 3 of those theorems are together. And what's the third theorem say?
Here, just a sec. Then the angles are angles. Sorry about that. Okay, so for number 4, 1 and 2 are right angles. That would be theorem. Let's see here. 1 and 2 right angles. Would it be theorem 3.9? If 2 angles are perpendicular, then they intersect to form 4 right angles?
Yes.
But Would that be it?
That's it.
Okay.
In other words, in my book, the three pictures shown for these three theorems are
Uh-huh.
the exact three pictures that you're looking at here.
Okay.
They're not different at all.
Okay. Okay.
So it was easy to recognize those. Okay,
Yeah, it
now we're
is.
going to apply the theorems.
Uh-huh.
And this is much easier.
Okay.
Okay, what's angle 1?
Intersect to form.
For number 5.
Okay, just a sec. Okay, sorry about that. Okay, so number 5.
Uh-huh.
So for this one, we know that the angles are complementary
Okay.
because, because it has the right angle symbol
You
to it.
don't even need to justify it at this point. In other
Okay.
words, at this point, it's just applying it. This is
Okay.
typical geometry.
Yeah.
Whereas all you have to do is solve for one of the angles. You don't have
Okay.
to justify it by a theorem.
Okay.
What do we know about 65 degrees plus 1? What does that equal to?
25 degrees. Well, they're both equal to 90
Okay,
degrees.
add to 90. They're complementary.
Yeah.
Okay, so 1 is 25. How about number 6? What is 1?
Is equal to 25 degrees. And then, so for number 6, it would be 90 degrees.
Okay.
Because the two lines are perpendicular and linear to each other.
Also, those happen to be vertical angles.
Uh-huh.
So you wouldn't even need all that perpendicular stuff. In other words, because they're vertical, angle 90. But also, that other theorem 3.9. How about number 7?
Vertical to each other. Okay, so for number 7, so you would just do 90 minus 38, right?
You got it.
Alright, so
52.
Yeah, 52.
Let me tell you, a good skill to have for geometry
is
going to be subtracting numbers from 180, primarily.
Okay.
But a secondary good skill is subtracting numbers from 90. In other words, what we have in problems 5 and problem 7 is complementary angles. So you're subtracting from 90.
Okay, yeah.
Most of the time, a typical geometry problem is figuring out one side of a triangle when you know the other two angles, and that's always subtracting from 180, or a linear pair, which is always subtracting from 180. So for the most part, you're subtracting from 180. So it's really good to figure out how to subtract, say, 87 from 180. Getting good at that. And unless you have a calculator glued to you at all times, then you can use the calculator. But if you don't, there's a couple of techniques you can use to subtract numbers from 180 that are pretty cool.
Okay.
But I don't know. We'll see if you need those when we get to those problems.
Okay.
About number, you said, is 8 part of what you need to know?
It is, yeah. So it's just 1 through 17. Yeah.
So, how do we prove that M is parallel to N?
So we know that they're both M is parallel to N because M and N are both 90 degrees, which means they're linear, which means they both add up to 180 degrees.
Okay. Let's see.
Okay.
I think they want the exact proof. Proving lines are parallel. In my book, it's section 3.4.
Okay.
Probably a lot different in your book. But it basically says that, well, let's talk about this because I kind of hate the way geometry teaches this.
Okay.
So I'm going to tell you how to do it my simple way.
Okay.
If you have two parallel lines and a transversal, you create 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. But you really only create 2 unique angles. And that's 1 and 2. Every other angle on there is either 1 or 2.
Okay.
Furthermore, 1 plus 2 is supplementary.
Okay.
That's all you have to remember for parallel lines and a transversal.
Okay. Yeah.
Okay? Now, they have about 6 different theorems and corollaries
Okay.
that say that, 3 is equal to 6 because they're alternate interior
Okay.
angles.
Uh-huh.
Let's go through that terminology because they're going to force you to, even though I don't like it. In other words, what I have drawn here explains everything.
Okay.
Okay? Because notice that 1 is the obtuse angle, 2 is the acute angle.
Mm-hmm.
So any angle that you see here that's obtuse has to be the same measurement as 1.
Okay.
So 8 is equal to 1.
Uh-huh. Because they're alternate exterior angles.
Well, that's the official reason.
Okay. Yeah.
3 is equal to 6 because they're alternate interior.
Interior. Yeah.
4 plus 6 is equal to what?
10. Wait. Well.
That's good. I like that. That's fun. I needed a laugh tonight.
Sorry.
Angle 4 plus angle 6 is equal to what?
So 180 degrees because they're linear. They're linear to each other.
Well, yes, exactly. That's actually called corresponding angles.
Yeah, corresponding.
So
yeah.
they have a theorem that says 1 is equal to 8 because it's alternate, meaning it's on both sides of the
Opposite
transversal.
sides. Yeah.
And it's exterior because it's outside of the parallel lines.
Uh-huh.
Whereas 3 and 6 are alternate because they're on the opposite side of the transversal.
Okay.
But they're interior because they're inside the parallel lines.
Okay. Yeah.
Okay? So they have all of those complicated theorems to tell you what's equal to what.
Mm-hmm.
But all of it really can be replaced by what I said, which is you only create 2 angles. You create an obtuse and an acute.
Mm-hmm.
Every other angle is either one of those, and all you have to do is look at it to tell. 3 is acute, so it's the same as 2.
Okay.
7 is acute,
Uh-huh.
so it's the same as 2. Now, the only problem they could give you that might be tough would be if they gave you 2 parallel lines and a line that looked close to perpendicular.
Okay. Yeah.
Now, those theorems kind of come in handy because maybe they don't tell you that those are perpendicular. They just show you a line that looks close to perpendicular.
Mm-hmm.
So in this picture here, what angle is equal to 1?
Angle 8.
Okay, that's 1. What other?
Angle 7, right? Or, yeah. Or, well.
No.
No. Yeah.
Angle 5.
Angle 5.
Remember that 5 is vertical with 8.
Yeah.
So 5 has to be
Yeah.
equal to angle 8. And what other angle has to be equal to angle 1?
Angle 4.
Yeah.
Mm-hmm.
Okay. So notice that this fits one of the theorems. And the only reason I need it is because I drew it in a way that you can't really see which is the acute and which is the obtuse.
Okay.
That's almost never a way they're going to give it to you.
Yeah.
Every problem you get on the ACT exam is going to look like this. Okay? The only thing they might do is throw in another line like that.
Okay.
Just to confuse you. Because now we have 2 transversals.
Mm-hmm.
And so we would have to deal with this angle and this angle. and that angle, and so forth and so on. So that's all they can do. This is the simplest proposition in the world. The only thing they can do is try to confuse you by throwing in a second transversal.
Okay. Yeah.
Okay.
Okay.
All right. Let's go back and look at the problem here.
Mhm.
So explain now. Let me finish what I was saying here. All of the theorems that say that 3 is equal to 6 and 1 is equal to 8 work in reverse.
Okay. Yeah.
What that means is that if 3 is equal to 6, then this line is parallel to that line. It's if and only if. Now, not all theorems are like that. If I told you if you live in Colorado, you live in the United States, is not an if and only if. You know, that does not mean that if you live in the United States, you live in Colorado. But for these things, it is if and only if. In other words, if these two lines are parallel, angle 3 is equal to angle 6. But also, if angle 3 is equal to angle 6, then these two lines are parallel. Okay? So, if we look at problem 8, we see that that angle's 90, that angle's 90. Well, we have that theorem that says is that when one of them is 90, all four of them are 90. So, all four of those are 90, all four of those are 90. That means that angle 3 is equal to angle 6, which means line M is parallel to line N.
Okay. Yeah. Okay.
Okay?
Cool. Okay.
Number 9. If X and X, this means that whatever X is, it's the same number. So what is X?
X would be 90 degrees because...
Yeah, because it's a linear pair. They have to add to 180, and the only thing that's the same thing that adds to 180 is 90.
90, yeah.
Which makes number 9 identical to number 8.
Yeah.
Because that's 90, that's 90. Well, we only need one of them to be 90 before we can figure out that all 8 of them are 90.
Yeah.
And
exactly.
If they're all the same, then you can use any of the corollaries to prove that M is equal to N. And I do mean any of them, because part of what I don't like about geometry is they give you like 4 or 5 theorems regarding parallel lines and a transversal. And you don't need 4 or 5 theorems, you need one theorem. That was the one I gave you. Okay, what about number 10?
Alright, so number 10 would also be 90. Because, since...
I don't even care about that there. I don't even need to know that. If X is equal to X, that's angle 1, that's angle 8, right?
Yeah.
So if those are equal to one another, then line M is parallel to line N.
Okay.
And like I said, we don't need that piece of information. You could take away that right angle right there. It would not matter.
Yeah.
As long as that's X and that's X, then that's parallel to that. Because those are alternate exterior angles.
Yeah, exactly.
One is equal to the other.
Okay.
All right. Which problem next? I'm never sure which one of these you need to do.
No, you're good. Number 11. Yeah.
Okay, this is a tough one to do online. It says, it says explain how to draw two parallel lines using only a straight edge and a protractor.
Well, you just draw two straight lines that are parallel to each other.
It's not as easy as you might think.
Okay.
In fact, I was looking in your book, and it showed how to draw a perpendicular line. And of course, if you could draw a perpendicular line twice,
Mm-hmm.
then you'd have two lines that are parallel.
Yeah.
In my book, it's page 130. And
Okay.
it is section 3.1.
Okay.
See if you can find it, because it shows a picture of a compass.
Okay. Yeah. Let's see. Page
And
130.
it's a perpendicular to a line.
Yeah. It has a picture of a compass on it.
Yeah, I don't know what page it is in your book.
Yeah.
But it's at the beginning of chapter 3. Almost certainly, even in your book.
Okay. Yeah. Let's see.
And it's a brown outline with a dotted line that says a perpendicular to a line. And it's got two pictures that have a picture of a compass.
Okay. 3.1. Picture of a compass. No, I'm not seeing it.
Alright, well let me see if I can duplicate it.
Okay. Yeah.
On my notes.
Okay.
Whenever you're using a compass to do something, whether it's recreate an angle or create a triangle or whatever, almost always the first step is to draw a horizontal line.
Yeah.
Okay?
Okay.
Now, this is how to draw a perpendicular line. But if we can figure out how to draw a perpendicular, we know how to draw a parallel, because we'll just take the perpendicular line and draw another perpendicular line to it.
Yeah, exactly.
Okay?
Yeah.
So the first thing they do is pick a point P.
Okay.
And they draw an arc.
Mm-hmm.
Like that. Boy, how good is that? That is good.
That's good.
Then they put the needle of the compass there. And draw another arc like that.
Mm-hmm.
Not as good. And then they put, and in fact, you have to make sure that this arc is greater than half the distance.
Okay.
Otherwise, they won't intersect.
Mm-hmm.
Then you put the needle of the compass there without changing the measurement angle.
Okay.
And you draw the other arc like that.
Mm-hmm.
Well, then you take that.
And draw a line between the top point and the...
Hold on a second.
Okay.
I don't like this. Oh, I see. Okay. Now you use any straight edge to connect that with that.
Yeah.
In other words, this original point is critical. They call that P. In other words, that's where your needle started to draw this big arc here.
Okay.
Yeah. Okay. And then you moved your needle, and I don't know if you need to change. And notice one thing about a compass. Compass is a linear measuring device. That is all that it is.
Okay.
Has nothing to do with circles, has nothing to do with angles. Okay. It is a linear measuring device. Notice that if I take a linear measuring device and I measure something, I get an arc. Why? Because that distance is the same as that distance, is the same as that distance. In other words, the only thing I'm doing here is measuring out those 5 distances.
Yeah.
It's all a compass does. But because you can draw an arc that represents every point on that arc is the same distance from this point, then it means you can do stuff like draw angles and triangles and parallel lines and perpendicular lines.
Okay.
But
yeah.
It is just a measuring device. Okay? So we're able to draw a line that's perpendicular to our horizontal line.
Uh-huh. Yeah.
Well, if I wanted to draw a line that was parallel to our horizontal line,
Mm-hmm.
is all I have to do is do the same process
Mm-hmm.
and make sure that that line is perpendicular to that dot.
Okay.
So any line that I draw that is perpendicular to this perpendicular
Mm-hmm.
will be parallel.
Okay. Yeah.
So I don't see anywhere in your book where it tells you how to draw a parallel line using the compass. But
Yeah.
if you use the process that it shows you how to draw a perpendicular line twice,
Mm-hmm.
then you will automatically have a parallel line.
Okay. Yeah. Okay. That makes sense.
Okay. In other words, the process for drawing a perpendicular, just duplicate it.
Okay.
All right. Now, I know we're over the time. What would you like? What are you supposed to do tonight? 1 through 14 or
Yeah, 1 through 17.
1 through 17? Well,
Yeah.
what do you want to do?
Yeah, I think I understand like the rest of it on here.
Okay.
So I think I'll be alright, yeah.
Okay. We can stop then.
Okay.
I won't run you late.
No, it's okay. No problem.
But, yeah, it's as long as I don't have a following appointment, I'm always happy to go over if you need me to.
Okay, yeah,
So
I appreciate that.
keep that in mind, and I don't ever mind. And I will only charge your mom for what time you use. If we go 40 minutes, I'll only charge her for 40 minutes. So
Okay,
you
awesome.
don't need to cut it off at 30 minutes if you don't want, if there's one or two more problems to go. But if you only want to do a 30-minute session, I certainly understand, and we can.
Okay, yeah. Awesome, well, I appreciate that.
Okay.
Okay.
All right,
Awesome.
Dylan, and by all means, always feel free to call me on short notice. I have no problem with short notice.
Perfect, I appreciate that.
Sure.
Awesome, thank you.
All right, talk to you later.
Okay.
Bye.
Alright, sounds good. Bye.